Example 4. Write these as logarithmic equations in base 10. Okay, so first, before we start, let us say something. In this exercise, we will suppose that all the variables used here, so in part A, for example, y and b, here the variable p and n and so on, all of them are positive. Let us suppose that. What we do in what follows is true only when this requirement is satisfied. So what we need to suppose is that all the variables here are positive, and having supposed that, we can try to write these as logarithmic equations. So in part A, I will write this equation y equals a squared b. And now let me take a logarithm of both sides. So if this is true, then also the logarithm of y should be equal to logarithm of a squared times b. Okay? So taking the logarithm of both sides of this equation doesn't change anything. The equation still holds true. If it was true for the original variables a, b, and y, it is still true now after taking this logarithm, but there was this requirement that all those variables be positive. Now, I will leave the left-hand side without any change because it's already in its simplest possible form, so it's just logarithm of y equals, and here I have the product of a squared and b. So I can use the logarithmic law and replace it by the following. It's the logarithm of a squared plus the logarithm of b. And I can go further because logarithm of a squared, it's the logarithm of the power, so I can use the third logarithmic law to rewrite it as 2 times the logarithm of a plus, and copy the last term, the logarithm of b. And here is my answer. So the equation that I transformed this one to is this one. So this is the logarithmic equation. This is true for logarithms, and the logic of this is as follows. If this is true, then this must be true. But it works also the other way around. If this is true, having required that y, a, b are positive, then also this first one is true. So these two are equivalent because logarithm is one-to-one function. So if you know that two logarithms are equal, then it means that the numbers they are taken from are also equal. This has to do with the fact that logarithm is one-to-one function. So this is equivalent to this, having supposed that all the variables there are positive. So it's just a different way how to write an equation, and sometimes it may be very helpful, as we will see later on. In part B, we have the equation y equals a over b to the power of 3. So if we want to rewrite it using the logarithmic equation, so let me take the logarithm of both sides. It's the decimal logarithm. So on the left hand side I have logarithm of y equals, on the right hand side I have logarithm of the quotient a over b to the power of 3. Now logarithm of y equals, now I can use the second logarithmic law about the logarithm of the quotient, so it's the logarithm of a minus the logarithm of b to the power of 3. Let me use brackets here. I could have used simple brackets like this. Now here I have the logarithm of the exponent of the exponential, so it's still possible to replace it by something simpler. So I will copy the left hand side. It's the logarithm of y equals logarithm of a minus, and now the exponent comes to front, so it's minus 3 times the logarithm of b. And here is my second second answer to the second exercise. Okay, so the last part is C. It's p equals 20 over square root of n. So in part C we have p equals 20 over square root of n. So this is the equation. Let me check it. Yeah, and what we need to do again is to replace it by the logarithmic with the logarithmic equation. So again, take the logarithm of both sides. So on the left hand side I have the logarithm of p. It should be equal to the logarithm of 20 over square root of n. Now I'll leave logarithm of p without any change, and here I have the logarithm of the quotient, so it should be the difference of logarithm of 20 and logarithm of square root of n. Now square root, as you may remember, square root of n is nothing else than n to the power of 1/2. So here this is the logarithm of n to the power of 1/2. So let me copy it again. Logarithm of p equals logarithm of 20, and logarithm of 20, let me leave it without any change, minus, and here I have the logarithm of n to the power of 1/2, like this. So it's time to use the third law of logarithms and replace this by the product. So it's the logarithm of p equals logarithm of 20 minus 1/2. This exponent goes in front of logarithm, and I have the logarithm of n. And this is the third answer in this exercise.